Okay, so this is a brief introduction of what each one represents in matrix formats and especially in vector format as well, of planes and lines. Okay. So we want to give a geometric interpretation of the vector 1, 3 in 2D and a vector u in 3D means 1, 2, 3 in R3. Okay. So the first one's easy, right? It's just simply just the xy plane. So this vector representation goes 1 across up 3. Like that. Just like a normal vector. However, in R3 now, it gets a little bit more complicated to plot points, well, especially points, let alone just lines in R3. Okay, so let's see. So we go 1 here, then 2, it's about here, and then we go up 3 in the z-scaling. So kind of like right there-ish. And that's what makes it more difficult because you got to rotate this way and then up again, right? But again, these are just vector representations of it. Just a little brief introduction to it. But what we care about the most is how it's written. And that's what these next two examples is. So give a geometric representation of the following. Of a subset W of R2 defined by this. Okay? And this is the key thing we're going to be going forward is how this structure is stated. Okay? So this wording is a little different. This is saying any vector x such that vector x is the component x1, x2, where x1 plus x2 equals 3. That's pretty much all that says. So we have constraints on it. That's what's happening. So it's any point or any vector as long as it follows these categories when it comes to its components. Remember, these are just straight numbers, right? x1 and x2 are just straight numbers. This is the vector itself. Okay. So let's see. So if I just rewrite this, and let's say we have this now, that kind of gives us a line. Right, if you follow that format. Because if one gives you 0, we're at the top of it. And if the other one gives 0, we're at the bottom of here. So this actually is a line in 2D. So this is line W. Or if you want to call it x plus y equals 3, like I have it there. Okay. So now what if we have it in 3D? So W is a subset of R3 defined to be this situation. Okay. Now again, what they're saying is in three-dimensional space, so in the x, y, z category, I think I switched it around sometimes. x1 and x2 could be anything I want it to be, but z is strictly 2. Okay. So which means if I go to z equaling 2, and I think of it in a two-dimensional plane, like y equals 2 in 2D, that's just a horizontal line. So same thing happens here. It's a horizontal line because z is strictly constrained to 2. However, y and x can change however I choose. So if it could change whatever I choose, therefore, I get a plane. Right? An infinite plane going, so an infinite sheet of paper on z equaling 2 axis. So this gives us, so W is a plane. So plane equation, z equaling 2.